School, the future of our planet and the global environmental change.
Oh,
yes, it's a part. Your lecture is a part of this seminar, and the next lecture also will be part of this seminar. And we have our guest. I'm honored to convene the lecture of Professor Dr. Ahmet Ruhi Mermut, who is a great specialist in soil mineralogy, soil genesis, micropedology, and organic matter dynamic. He is a professor of two universities, the University of Saskatchewan, Department of Soil Science, and another Department of Soil Science in the Harran University in Turkey. And I think that most of the people attending this lecture somehow know Professor Ahmet Mermut, because for many years, he is a very active person, traveling all around the world, attending the most famous conferences and congresses. And he was very active in IOSS, International Union of Soil Sciences. And he is still a honorary member of this union. For many years, he was a chair of Division 1 of the IOSS. And then he was a president of the European Confederation of Soil Science Societies. And it was also a very difficult time for Turkey that year. Yes, you remember the postpone of the Congress. It was first scheduled on September, yes, and then it happened only in late October in Istanbul, Turkey. But it still was a great event, and I have very good memories about this. Professor Mermut received many international soil science awards, and of course he taught courses on soil science not only in his university but outside, like in the University of Toronto in Brazil and several other countries. And he played also a big role as an editor of distinguished international journals like Canadian Journal of Soil Science, Geoderma, and so on. And today we'll have a pleasure to have his lecture, The Rate of Pedogenic Carbonate Accumulation in Canadian Prairies. And why it is especially interesting for the Russian audience, this is because these soils of these Canadian prairies formed mostly in glacial till, yes, as I know from the presentation of this lecture. And so we have similar environment in the
exactly.
Yes, in the glacial areas of the Russian plain. And so I think it would be quite interesting for us to have this lecture. And now I should say the magic words that will start the recording and the retranslation of this lecture to the YouTube channel. Sergey Valerievich, мы начинаем. And now I give floor to Professor Ahmet Mermut, please.
Yeah. So how I'm going to switch from here to,
Yeah, you should start on your presentation.
All right. Rate of carbon, and actually I'm interested very much of carbon in organic form and inorganic, especially pedogenic carbonates.
Sorry, Ahmet. Did you put on your presentation? We don't see it.
Yes, I did.
But we don't see it.
You don't see it. Okay.
Share it with us. Okay. And now you should put on the, yes. Yeah. Okay.
Okay. And I have said now as title as rate of carbon. And in my early stage of career, as we all know, that organic matter in soils everywhere in the world is just a couple of percent, 1-2. In most of the soils in Turkey, it's just about 1-2%. In many places, is maybe 3-4. And and majority of soil that I was interested to study is inorganic. So I started with minerals, and minerals are quite exciting. But then a couple of percentage of carbon plays a very significant role that I understood in my career, that one should not ignore and do a good study on this. And before starting to put the ideology in place, and I want to point out that there is a need, as I think, as we are also interested for carbon because of food security. Everybody is interested on food security. Carbon is part of it. And then in relation to that, as we see that population increases, and 2050 is world population is expected to be double, triple. And this requires to look at the global distribution of carbon forms and etc. So I think that major problem lies in Asia, as we can see it as in the slide, and also in Africa. In Europe and other places, increase is not that great. In 1952 continents, is Asia especially, and Africa. Luckily, Africa don't have enough population these days, and temperature, we all know that it increases even half a degree, but it's we consider it as substantial and very important. Now, we all recognize that carbon is the source of life. How come that carbon is source of the life? Yeah, carbon dioxide in the air is inorganic form, and water with energy from the sun. I think this equation is very simple, simplified, but it's extremely important to understand it. It's converted with the energy that comes from the sun, and it's converted carbohydrate. Carbohydrate means organic substances, myriad of organic substances, and oxygen. When you go to the forest, and you have a lot of oxygen during the daytime, and carbon can occur in inorganic form, carbonic acid and carbonates and so on. And here we see organic matter and plus oxygen and equal to water and carbon dioxide, and energy comes out. What does it mean? I think it's very important to recognize that the carbon locked up in any organic forms can produce energy, which is very, very important. There's conflict in the world, as it is basically derived from finding energy from any source possible. I can see the possibility, especially oil, for instance, in Brazil, sugarcane. They produce a substantial amount of sugarcane, and they use it as fuel for cars and other places. So I think we should finally think in terms of the sun energy that is locked up in organic substances, any organic substance. Then energy comes out, and water and carbon dioxide, then energy, it recycles all the time. But carbon we should not forget that it plays a very significant role. And sunlight, carbon dioxide, water, and then oxygen comes out, and glucose or organic substances. Yeah, where's the carbon is locked up, and there are a lot of figures around the world, but this one is just a general one that I'm interested in very much. And ocean keeps a substantial amount, and then every year 2 petagram or 2 gigatons of carbon that goes to the ocean every year. But on the other side, we have 6, these days maybe 7, 8 petagram that comes from the burning of fossil fuel. But the balance that comes from the soil respiration and respiration from the plant, which makes it 120 more or less, and it goes in, and this two things goes out. It's balanced it out. But what is that? As we don't know, pedogenic carbonate that's locked up in soil, and actually carbon dioxide from initial stage when human being was not on Earth was much higher than, someone says 1,000 times more than what is today. So there was no way, even in Miocene time, and 3-4 times much higher. We're talking about elevated level of carbon dioxide in atmosphere, but through the history of geological time, we had much more carbon dioxide in the air. Then what happened to it? I'll show that in the Miocene, carbon dioxide much higher than it was today. And before the formation of limestone on Earth, maybe it was much higher. As some people say, so I've seen a figure saying 1,000 times is more than what is today. And majority of this carbon dioxide, where does it come from? Geologists has pretty well understanding of what happened from initial stage and what is going on right now. And rocks as carbon limestones around the world. Now, people have studied, and I think as a soil scientist, we cannot really leave carbonate rocks or limestones and talk about something else. But it is very important that we look at the carbon dioxide limestones. Today is that I want to share with some of the things that I'm very much interested in: inorganic carbon stocks, and as a secondary carbonate in for instance Saskatchewan, which is more or less as you have said, and it is similar to what you have it here. And even what Dokuchayev in the past have discovered the zonality. And I found it myself in Saskatchewan when I arrived. Fortunately, I had traveled by car 700 kilometers through the Rockies in the north and the US-Canadian boundary. One can see this zonality quite nicely. And I think everybody can see a secondary carbonate, and when you open up a profile, I open up somewhere around 107 profile through this 700 kilometers with my students, poor students from Iran. We dug by ourselves and looked at secondary carbonates and organic carbon and try to find out the relationship and what is happening right now, what happened in the past. And the beauty is that you can reconstruct paleoclimate and paleoecology, especially plant species and whatnot. This is really very beautiful from my standpoint of view, and still lots one can learn from this study. It's good for graduate students and research in this area. Well, luckily, we have very simple instrumentation that we can measure nitrous oxide, methane, and carbon dioxide, and water, and ammonia, etc. So very simple machines is now available. We can measure it so for the balance to find out. And this is map of Saskatchewan, but here is what we have: 16,500 and then 10,000 years at the very top. So this is granitic rock. We have gold in it and in the veins, and very pure, I have seen with my naked eye. And this is the boundary of deglaciation from almost 17,000 years. This is US border, US-Canada border. And then it goes almost 7,000 years from here international border to the granitic rock area. And I admire the guy who really drew these lines, a geologist, pedologist, deglaciation history. And this helped me quite a bit. So when I opened a profile starting from this gray area to the international border, more or less from here to here, international border, 700 kilometers, I mentioned that I opened up 107 profile and looked at the secondary, picked up the secondary carbonates, and we looked at organic matter at the surface, soil, and also secondary carbonates in the profile. And you are very much familiar, and I have seen in many places your Chernosians and secondary carbonates. And in my student period, then even I saw in Luz in Poland, for instance, and it attracted my attention. Now I understand it a little bit more closer. And this is the soil map, is more or less from, you can see it from the other map that I have shown to you. And when you travel from the north to the south, then you cross the black, what we call it, brown soil, dark brown soils, and brown soils, just like you have the zonality here in Russia. And of course, I think it's probably it formed under the same circumstances and climate and temperature. And what is secondary carbonate? Everybody knows. I'm sure that people studied, lots of people study and around the world, but these are a profile that indicates a large amount of secondary carbonate here, and it is less than, much less in this very deep profile, and here it's much less. And when you look at, you can even determine the age by C14 values, and you can determine the H, and at the same time carbon and oxygen isotopes will give you idea about temperature and past climate and past vegetation. What was it like at C14, C4 or C3 plants, and what sort of a plant, and so on. Here is a landscape, and pretty much is what you have it in probably south of, I haven't traveled south of Moscow to Black Sea. I'm sure that this landscape is pretty familiar to you, and the carbonate zone right here, secondary carbonate, and the black soils right at the surface. When you come and look at the landscape and profile, you feel that you're at home. And travel that I have made to the east, especially Siberia, and many places I have seen profiles, and that really helped me very much to understand a little bit better what I've seen back in Canada. So stable isotopes, as we all know, that elements, light elements, we see as light elements here from hydrogen to oxygen. And the isotopes, especially hydrogen and deuterium and tritium, and some people have developed boron 10 and 11. They work on boron these days, and carbon 12, 13, and 14 is radiogenic, as we all know. Nitrogen people in Brazil, they enrich N15, and they study nitrogen cycles and so on, and I admire them. And oxygen is 16, 17, 18, and oxygen 17 is not a high quantity, but oxygen 18 is reasonably high. So then oxygen 16 to 18 is to help us quite a bit to do isotopic studies. And this is the isotope distribution in several different terrestrial environment, and atmospheric carbon dioxide, that's starting from atmospheric carbon dioxide, and also carbon dioxide that comes from the fossil fuel. And the C3 plants is 27, C4 plants minus 13, and then chem plants is between 10 and 20. And these are very important, catchy figures that one can utilize to reconstruct and see what you have it when you measure it and you look at these figures, and you can see what's going on. And here is that you can see coal, natural gas, and petroleum, for instance. Petroleum, you have quite a bit of petroleum environmental risk in Siberia, and one can study what is happening really by stable isotopes as carbon that is there. And it's an incredibly beautiful technique as from my standpoint of view. Here we see the total organic carbon, and I showed you the zones, brown and dark brown and black, and this gray is something else. And regular black chernosium, this is something else. But when we look at this thing, and we were able first time to determine using this deglaciation history, and I was able to recognize the date more or less 100 years or maybe even 1,000 years earlier or later. Doesn't make very much differences, but I could calculate when the soil started to form and when organic matter started to accumulate. So based on the time that profiles started to develop, and I just divided simply and find out this, and in 1.2 meter depth is kilogram per square meter, and for instance, this is on daily kilogram per square meter and 1.2 meter deep. And it's quite interesting. Here we see the thickness of the soil, and it increases as you go from the north to the south to the north. And here is the rate of pedogenic carbonate as gram, meter square, and year. And first time in the history, we have published papers and also find out establish this, for instance, brown, dark brown, black, and gray in different zones. And gram, I want to underline gram per square meter per year. And based on deglaciation history, that was a very important catchy point for me to start with soil development, the age of the soil, and organic matter and secondary carbonate. For that reason, I think is you can go to carbonate, original carbon. You can differentiate and huge differences isotopically between secondary carbonate and limestones, so that you can find out how much original carbonate as limestone you have in the soil and how much is secondary carbonate. Once you establish the basic figures, then you can go on. And here what is pedogenic carbonate? And Galicia, especially Mediterranean region, and I'm not sure whether Galicia exists as any place, maybe in southern flanks of Russian Federation, and a little bit more arid region. I cannot say very much, and people may speculate and say something about it. But what we discovered is very, very important, and secondary carbonate basically derived from organic matter in the soil. If you remember, the equation that I have shown to you is organic matter goes to inorganic, inorganic goes to organic, and it's just a matter of energy, carbon dioxide, and water. So we can look at a lot of people looked at the carbon dioxide as gaseous state in the soil, and also atmosphere. Atmosphere is changing all the time. Luckily, a lot of measurements these days going on in North America, and we can see how much is carbon dioxide. It's phenomenal that agriculture, we are so interested, I am so much interested from the standpoint of food production, and yet you see that agriculture releases 20% and more carbon dioxide from just simple agricultural activity. And when we think in terms of carbon dioxide, increased carbon dioxide and increased temperature, and we make a lot of noise as in the West that I don't like it very much. And we make a lot of noises about the temperature increase, but I'm not sure what we are talking about. I think it's, we still need to measure zillions and millions times of gas and liquid and also solid phases of rocks and minerals and find out really what is going on. And for me in Mediterranean region and maybe in California, the same thing. The caliche is phenomenal. And you can determine more or less up to 50,000 years, you can determine the age of when it was accumulated. But there are some other way of measuring the age, as definitely, I'm not going to make any point about this, but definitely C14 radiogenic carbon help us in the last century, help us tremendously to really measure, and we have to continue to measure it. Now, organic matter in the soil at the surface, and it's also deep in the profile. And we have C3 plants, C4 plants in Saskatchewan. I'm sure that in the zonality you have here in Russian Federation is more or less the same. And we can find out, I think is a fundamental aspect is very well established in my view, but details we don't know, as we don't know many things, and we can discover. And this is a good thing for graduate students to do a study. And measuring, we have just in soil science department 3 people. We have designed a project submitted to Canadian government, and we get $500,000. And so it's there, and we charge ourselves for $10 for one sample. I'm sure that MSU and here is Moscow, you must have also equipment to do this. And so simply this looks to me a great things to measure and figure out what is really going on. And yeah, organic matter, any depth should closely reflect the relative contribution of organic matter from C3 plants, C4 plants. It's, and when I make a point to my students, even they don't understand it. They don't understand that the secondary carbonate, as pedogenic carbonate, basically come 95% and more from organic matter. And C3, C4 plants, well, we don't have it. And plants is very much. And the isotope composition of soil organic matter determines the isotope composition of pedogenic carbonate with high respiration rate, where diffusion dominates mass transport. This is what we say. What is really very much interesting, and when you look at this is geologist work as that I have taken, and the age is from 0 to 4 billion years. 0 to 4 billion years, and this is this C13 of carbonate rocks, limestone rocks. And what tells us this, that world is completely covered by ice at one time. It's very, very difficult to visualize this, but I think it's so far measurements taken place by mainly geologists indicates that the world was covered, the eye is white ball, is right, you can see it here, and many times. And it says 800 million years, 600 million years, and 2.3 even billion years. So then I think is we have to put our cap on the table and think about all this. And limestones in Europe, and we can see here where limestones are, and this is carbonate rocks and around the world and regional boundary, and we can see it in this. If I just neglect this one, and if I neglect this one, I just want to get rid of this. I cannot do that. But it's a lot of limestones in Turkey here, and you have in this area in Russian Federation, and also here and especially in Mediterranean area, ex-Yugoslavia, Italy, and France and Spain, etc. And I have seen in those in southwest Turkey, and currently I am teaching here in this area. And even on Mars, that I'm very keen. My daughter is now a professor at York University. She's chemist, but she's working with physicists and also astronomers and astronomy department, physics and astronomy department. But then really it's quite interesting to note that calcite, dolomite, iron oxide, ankerite, magnesium, iron-rich carbonates, and magnesite, and so on, exist on Mars soil. So what it means, I think it's very clear to me that Mars, based on a lot of papers is now coming out, and astropedology becomes a very interesting subject matter for pedologists like myself. And I'm Professor Makiev, I'm sure that he's interested as much as I do, and shows quite clearly and sedimentation and also carbonate. And I'm sure that some people have already, I didn't dig out, and I'm sure that some people already done isotopes from a long distance. Material soon will arrive. I hope that through my daughter and I will have a little bit of material to look at the mineralogy, because the organic matter is probably zero level, most likely, and we don't know exactly until we see the samples itself. But that's what it is. And I want to end my talk here, Professor Makiev, and whoever listened to me, and I'm thanking to them. And I should thank to Professor Pavel Krasilnikov and also Olga Yakimenko, and for their help and assistance for me to organize my trip in these very difficult days. But we scientists, I'm sure that scientists before me and a long time, and they suffered quite a lot as under much difficult condition. I pray Almighty that that will ease off tension anywhere in the world on human being. And I want to thank for those listen to my presentation. If any question, I will be glad to answer it. Thank you very much.
Okay, thank you, Professor Mermut. I think that those who want to put questions will start in a normal way, and you know how to raise hands. I see the screen, so I can notice you. Please put on your questions. I don't see any volunteers by now, but then I start myself. In the announcement, you mentioned that you studied also the difference in isotopic ratios on different slopes, like southern slope or northern slopes. So we have influence not only between soil zones or different landscapes.
Sure, absolutely.
But also we have differences on slopes. Can you please explain it somehow?
Yes. I think it all depends as organic matter. And those facing to the north, moisture-wise, is a little bit higher than those slopes facing to the south. So it produces more organic matter, and organic matter content is north-facing slopes is higher, and the rate of accumulation is higher. And for the same token, a secondary carbonate, because I think it's very important to recognize that, you know, in early stage of my life, when I thought that secondary carbonate is just a dissolution of limestones and reprecipitation, but that's not. Stable isotope shows that the majority of it is 95 and more percentage come from the oxidation of carbon, organic matter, in other words. And then I think, and isotopically, when you look at it, and plant species even are different, and when you look at the south-facing and north-facing slopes. And of course, transport complicate the situation. And even though I think you can calculate the amount of organic matter transported and how much transported and so on, and isotopes are tremendous technology, in my view, to stretch your imagination and find out what's going on in a landscape. But that's what I can say. Okay,
I have another question, but nevertheless, you have carbonate debris in the soil, yes?
Yes.
Because it's mostly on glacial till, and normally glacial till has a lot of debris.
A lot of
differentiate in the balance. You should differentiate between secondary carbonates and primary carbonates.
We can calculate it. We can calculate it. When we establish a primary carbonate, isotopes of carbon isotope of primary limestone, let me talk about limestone, and then the carbon in organic matter, signals from organic matter, and also secondary carbonate, then you can, in the amount of even 1-2% of error, you can calculate the amount of, for the same token, using hydrogen and deuterium and tritium, you can differentiate even water, how much amount of water arrived to the soil system from snow. And for the same way as carbonate, as primary carbonate, very easy to calculate it and very reliable. And no problem with that. And I think it's that way we could make this calculation. I don't think anybody in the world has made and this kind of study, as far as I know now. And so, and that was one question when I arrived. They said, well, you are a pedologist. Can you tell us how much organic matter accumulates in the soil on annual basis? So this was surprising for me, but by studying the stable isotopes in geology department, very close to our department, soil science department in Saskatchewan, then I could figure out, and luckily figure out, how much secondary carbonate and also organic matter accumulates. I think this is extremely important. And we know that most of the carbon, especially organic matter, unfortunately lost through agricultural system. Agriculture is very important. Food production is very important. But on the other side, agriculture causes the loss of organic matter from the soil. Can you imagine? Now, what we have to do it, and soil management become extremely important issue for everybody around the world.
Okay, thank you. I think that, okay, Olga Khokhlova, but you should, yes, put on your microphone.
Dear Professor Mermut, thank you for your very interesting topic. But my question is, did you measure the radiocarbon age of your carbonates in the soils in Saskatchewan?
Yes, we did. And as you know, it's quite expensive. in one sample cost you $600-700, one sample, one single sample. And yet with stable isotopes, it's just we pay $10. So when we made an 107 profile, and my student was very much worried about it, and even hundreds of 200-300 samples, we paid a couple of $1,000 from our research fund. Then we were able to measure it, and radiogenic is possible. You can measure it. I'm sure that you have it here in Moscow, MSU University, and but it's expensive. Therefore, we just select few sample and analyze it. And but this should not be a question for any scientist around the world. And for instance, potassium argon, and that geologist using it. And I have a soil, and I found it basaltic soil, 10 million years old, and you can't do it with. But for one sample, I paid 750 euro in France, and it's not available everywhere, and it's just a few places in the world. And we have down east one university that I haven't located yet, but cost effective, and you have to think about all these factors before you make your decision.
Yeah, but my question is connected with your statement that all the pedogenic carbonates in your soils was formed during post-glacial time. You said,
yes.
Yeah, yes. You said at the beginning of your presentation that
yes, yes, for sure, and 25,000 years, something in that order of magnitude, and last deglaciation. And I found the remnants in southeast Turkey, a spot that I have looked at the radiogenic carbon, and we dated 25,000 years as a gravel layer within the profile. And I want to take Professor Makiev to that site especially, and he will be very much interested, I'm sure, about that, as that gravel all over the plain in Haran Plain, what we have it there, ended up with 25,000 years. And you know, Göbekli Tepe is a very important spot. These days became very, very much important, and that also spots as radiogenic and also stable isotope study showed 12,300 years.
Thank you.
Yeah, you're welcome.
Okay, we have a question from Maria Brodnikova, please.
Yes, Maria.
Yes, thank you. Yes, thank you very much, Professor Mermut, for your very interesting lecture. Probably I didn't get the part of your answer to Dr. Makiev, but I allow to myself to answer. If you have both primary and secondary carbonates in your soils, how can you estimate the rates of between primary and secondary if you estimating stocks of the carbonates in soils? And in this case, how you can estimate rates of carbonates accumulation?
Yes,
pedogenic carbonates accumulation.
Yeah, first you have to calculate. I think it's probably I was not clear enough to indicate on all this detail, and I was worried about time. And when you look at the stable isotopes of limestone, that you are sure that this is a piece of limestone, you have to make sure that this is a piece of limestone. So I'm sure that in profile here, in any place we open up, you can, when you pick up a carbonates and look at under binocular and also clean up with your hand, and and with your knife, etc., you can say more or less this is a primary is limestone, and if not, then you go to isotopes, and isotopes tell you exactly. Isotope tells you limestone exactly whether it is primary or secondary, and then
yeah, but if you have both, if you have both primary and
yeah,
secondary.
but in the north of Saskatchewan, we have limestones,
yeah.
Pure limestones, and we know that glacier mixed it up and carried and so on. We picked up, and therefore you have to do a lot of analyses, and you say, well, this is not good, and throw it away, but this is what I have it here, and also what I picked up in the profile is more or less the same. But pedogenic carbonate, I think, this is the crux of the issue. Is the most important thing is to recognize secondary carbonate. Powdery pocket, do you agree with me? Powdery pocket is more or less secondary, and dolls that you see in lush soils, the lush that you have it here, and I'm sure, and yeah, and then you pick up powdery pocket and you look at the stable isotopes. Once you establish what is your secondary carbonate ratio, stable isotope carbon 13 and 12 ratio, and per mil, and then you can, by just taking a soil sample and releasing your carbon dioxide and looking at the stable isotope, you can calculate how much it comes from primary and then how much from the secondary. No question, I'm very much convinced.
Thank you.
And I can provide as the methodology, how do we calculate, if you're interested in. And then
yes, I am.
Yeah. Yes, well, there's a PhD studies. I can send you the copy even of that PhD study. You can see and how we do it, and how we have done it. It took me 2 years, Professor Makiev, from the north to the international border to open up 107 profile. You can imagine, by hand, 2 meters.
Okay.
And then
thank you so much.
You're most very welcome, Maria.
Okay, please. Anybody want to put on question?
Yes, may I ask a question, Maria Gerasimova?
Yes, Professor Maria Gerasimova.
Okay.
Oh my goodness.
Yes, I am very happy to hear you, Professor Mermut.
I'm so happy to hear your voice.
Okay, I have such a question, a very simple question maybe. You are speaking about secondary carbonates in different soils, but remembering your micromorphological interests in the past,
yes, we have done it.
Differentiate them? Do you speak separately about, for example, pseudomycelia, or about nodules, carbonate pendants, and other
That's
forms?
an excellent question.
And no, it's not the end of my question, and it's first part, and the second part is whether these variants of secondary carbonates, do they have some attachment to soils? Can you say that, for example, in gray soils, pseudomycelia predominate, or in brown soils there are more nodular features, or something like this? Now the question is final.
Yeah, you are a great scientist that I respect, and no question about it.
Yes.
And this is why I have said that, you know, as you are just telling a graduate student to look at these aspects of it. So what we tried with geologists in Saskatchewan to release carbon dioxide from a spot of a thin section, and to measure and carbon dioxide released from, and let's say, any type of secondary carbonate, and measure at the same time as carbon and oxygen isotope. So beauty of secondary carbonate, not only one element, but we have oxygen and carbon, and you can measure also isotope of oxygen at the same time. And it makes you more secure in that regard. So I think probably a graduate student, just like we did, we try to dig out and develop a technique that we can release carbon dioxide from any spot under microscope, capture it and measure it at the same time, send it to the mass spec and then analyze it. It will be ideal, and so we can solve all our questions with this technology available to us, Professor Gerasimova.
Thank you.
Okay, more questions? Professor Gerasimov, are you satisfied? Maybe more questions? Okay, while we have a break, I want to come back to your astropedology point.
Astropedology, yes,
yes,
there
because,
you are.
What is your anticipation for the future, of course? Do you somehow suspect that the carbonates on Mars are somehow related to the former biospheres?
I haven't got the samples. I haven't studied very much, but I think it's from the existing literature, and also photographs, etc. It gives me absolutely that impression.
Okay.
So I think that also whether there was a life and what sort of a life, and yet there's a lot of question. It's astropedology is a value, I think, is a subject matter we all should be very much interested in. And I'm going to put maybe as two different views about this. It's from NASA. People works in NASA, and they promised to send me papers so that I can put it in this handbook of pedology. Astropedology, I think, is a very important for us to recognize it, and also for future generation, in my view.
Okay, please put on your questions. I don't see your raised hands, but probably you just want to ask something. No more questions? Okay, then we would like to hear your views on the lecture. Please, your comments, suggestions. Of course, the English is a kind of limitation, you can imagine, but nevertheless, we can somehow contribute something.
No, in this great country, I see a lot of people speaks very good English. They complain about their pronunciation. I wouldn't care a bit, as long as the other side understands you. The pronunciation is not that critical, in my view. And it's a lot of people that I have met that speaks reasonably very good English. In
the audience that's present here, we have people who are professionally linked to the study of soil carbonates, and maybe we may have some comments from them.
Yeah, I would be very glad as what they think about it.
Okay. Nikolai Borisovich, maybe you want to say something? No?
We are generally a little bit shy, and we shouldn't be in science.
Maria Gerasimova, please. Professor Gerasimova.
No.
No?
No. specialist in age and in stable isotope. I'm more speaking and more interested in geography, in the in secondary carbonates and their occurrence in different soils. And this is not quite the topic of this issue, of the lecture of Professor Mermut. It's just a bit another thing. So thank you. No.
Yeah, the general balance. Carbonates.
Yes.
Okay.
Yes, for sure.
Okay, then I say just a few words. We've really listened to a very interesting lecture. First of all, some landscape and some geography was present at the beginning. And this geography is quite different from that we have on the Russian plain, by the way, because we have only a small portion covered by the last glaciation, last glacier. And it's all inside the forest zone. But here we've seen that we have beautiful zonality within the last Wisconsin glaciation areas.
Well, absolutely.
Yes, and they're all covered by glacial till. They have fresh relief. But another point is that we have mostly hilly conditions. But you notice that in Saskatchewan, we have completely flat terrain. It's also very unusual.
Flat.
But I was astonished, first of all, when I was in Illinois, that moraine plains there and even end moraine parts of relief are quite flat. That is also very unusual. Then, of course, it's very interesting point that besides this bioclimatic zonality in a normal way, we also have this expositional zonality that influence the carbonates. And it's also very important for paleo landscape reconstructions because normally when study paleosols, we don't have this impression of relief. We have to speculate what it was, southern slope or northern slope, but we cannot be quite sure. And this we need to take into account. Then,
for sure,
coming to the historical sketch, I would say that there is now a lot of literature, maybe from ancient cratons like Australia or Canadian Shield, where we have soils of Precambrian Proterozoic soils that were formed during this cryogenian period. So that means that the concept of snowball Earth need to be verified from that point of view. It was, of course, very cold climate. That was frost soils, but still soils. So the biosphere existed by that time. So this need to be verified. And I'm very glad that Professor Mermut is very cautious with the predictions of the global climate change, of this global warming.
Absolutely, absolutely.
Because we definitely need to have much more measures. For instance, we don't take into account and we don't know nothing about the carbon stock in Jedama, for instance, in the Northern Territories, that comprise maybe about 1/3 or even more of the carbon accumulation in soils of the planet. So taking all this into account, we need to be very cautious about these predictions of the future global warming. So I'm very satisfied that we had this conceptual presentation, and maybe some of you still want to say just a few words about, yes, maybe?
Yes, probably.
Okay, Maria.
Maria?
May I?
Yes.
It's actually, it is very complicated subject about soil carbonates and pedogenic carbonates. The thing is that if I understood right, you said in the beginning that the main source, key source for the pedogenic carbonates are soil organic matter.
Exactly.
But I am not sure that it's, yes, I am not exactly sure that it is the case for all soils all over the world, because as I know from the literature, there are very different opinions on the sources of the pedogenic of the carbon in pedogenic carbon. In pedogenic carbonate.
Secondary carbonate, yes.
Point. Another point, I have my own very, not very big experience in the studying of isotopes in a pedogenic carbon, pedogenic pedofeatures in pedofeatures, and I should say we dealt with pendants with laid coatings on the stones. In cryo-arid soils, in the soils of dry cold steppes in southern Siberia. So we made preparation of these layered coatings and measured isotopes in different layers of these coatings. Prepared from the one sample, from one stone. And even these definitely pedogenic carbonates have very different isotopic composition, carbon isotopes. And we know that our soils have very little admixture of primary carbonates, but still, even in this small section of the pendant, the composition of isotopes could be very, very much of different. So it's too complicated.
Not very different, but they form sequentially, and from one, if you choose and one by accident a good one, then you can determine the age, and it's not formed in one time.
Yes, we did it. Yes.
And if you take a pendant, but they did form a different time. Different time means under different vegetation, and when you look at the time and when you.
But it's not always correlate with vegetation. It could be very, very heavy carbonate isotopes. Like 2 plus 2.
Maria, this is very interesting what you're saying, but it's secondary carbonate coming from the oxidation of organic matter is a reality, and a lot of people, a lot of geologists, and I don't remember his name, but it's a fellow from Salt Lake City. It's a good geologist, and I consider him as a pedologist. What is geology? What pedology is not a big question for me. And but he picked it up a lot of sample from Saskatchewan, and he published papers even in Nature. And also, I respect a guy, a physicist at the University of Calgary. Maybe it will be exaggerated if I say 1,000 sample, million samples that he analyzed, and seven people working in laboratory, and he works on forensic aspect of soil and also carbon isotopes, etc. And for forensic study, you just made me to say something about it. Is a tremendous power. But when you look at the organic matter isotope study, is a huge number. I think that's the beauty. It's easy to do it. And $10 a sample, as my students have picked up 200-300 and 2,000-3,000. It's not a big money, and a professor should have a substantial amount of research money and before attempts in doing something. And but I think it's at this point in time, nothing in science is 100%. We all agree on that. But as we know now, and the figures that is available for scientists around the world, I think as we are, I am included, and I'm convinced that majority of secondary carbonate come from oxidation of organic matter. But this is, you can argue about it, but I can suggest to you, as you increase the number of sample analyzed, you can start to put your brain into this matter, and myriads of things may come out. And I think this is probably just the beginning. But I was absolutely surprised to see that somebody suggesting geological aspect, that world was like a snowball several times. How many times? God knows how many times. One has to look at the detail. But it's now, as we have this phenomena, well, this suggestion, and if we may like it to say it, and organic matter, I think study of organic matter is also this, and the beauty is that we could calculate annual precipitation of organic matter, accumulation of organic matter. And we know that the samples they have taken in Saskatchewan, I'm not sure whether, I hope that you might have it here in Russian Federation, but people when they started in 1920, we have samples they have picked up from the zones. And I think they were all influenced by the development of pedology developed in your territory at one time. And people influenced in early 19th century, and then they have made a remarkable footsteps. And then we look at the samples, organic matter, and they have a samples in Calgary somewhere and deposit it. And you can go and take a few grams of sample, which is enough for you to look at what you wanted to look at it. But it's incredible. Within 80 years, 100 years of period, cultivation of Saskatchewan soils, we have oxidized. We have oxidized and almost 60–70% of organic matter. It's incredible, absolutely incredible. And so what do we do? I think is agriculture is good. As I'm not going to deny it, it's never ever, because then we have a food crisis on Earth. And which one you prefer? You want to die with no food, or you want to have organic matter? So who cares about organic matter in the soil when it comes to food security? And so it's a very, very interesting issue. It depends from which aspect you look at it. But luckily, people interested out there, and instrumentation, new instrumentations are there. And thanks God, as under any circumstance, with scientists, we can collaborate, we can talk to each other from a distance or face to face. Hopefully one day then we go back to normal and sit down and talk face to face. But this is a technique, is also we discuss and we try to understand each other. But for this time, I think is available information, I would say, that suggests that majority of secondary carbon, and there's a huge difference between secondary and primary limestones. And likewise, organic matter, and whether it comes from C4 plants or C3 plants or CAM plant and so on. And the technique is very simple and understandable. You can make a calculation of C3, C4 plants, and for the same token, we can calculate the primary limestones and secondary, etc. And of course, when you take a concretion of let's say doles, baby doles, in first time I saw it in Poland. On Lus, they have in eastern side, they have lush quite a bit, and I was surprised. Well, absolutely surprised. Kubiena was there, and I saw Kubiena and running from one spot to another spot, and they influenced our thinking, and we have to influence each other somehow. And in that regard, I think it's you have the people to inspire, but I expect more pedagogy from Russia.
Okay, thank you. So, other comments, please? Suggestions? Okay, thank you, Professor Mermut. And let me make another announcement that this week we'll have another lecture of Professor Mermut devoted to mapping, soil mapping in Canada. That is also very interesting, and you'll all get this information announcement by our group. Okay, if
Very great.
If nothing happens, then I want to thank everybody, and especially Professor Mermut, and stop the session. Yes, Olga?
Yes, I think so. Thank you so much. And thank you everybody who attended the lecture.
Yeah.
Ahmet, see you tomorrow.
All right. See you tomorrow. Have a good night.
Bye-bye.
Bye.